This is Harold Waters, OSU Extension Field Specialist for Agronomic Systems, and I'll continue on with managing nitrogen in Ohio. This time we'll talk about, how do we determine the correct rate of nitrogen. So in the past, we would use a yield goal to set our nitrogen rates. Perhaps the yield, the rule of thumb would have been 1.2 pounds of nitrogen per bushel of yield goal. And if we had a yield goal of 150 bushels per acre, we might put on 180 pounds of nitrogen. Today, we don't use that yield goal, those yield goal levels, to set the nitrogen rate. Low crop prices certainly fallen into $3.50, below $4 range. Today is considered low with a high cost for production. And then high nitrogen costs, even though the price of nitrogen has dropped off, it's still relatively high to the corn prices. So we use these economic models to set our rates for today. So why have our recommendations decreased? I'll put it in those terms as well. Modern genetics, plant breeders have really caused or created a shift in levels between starch and protein, and shifted to there's more starch production comes out of a bushel of corn and slightly less protein. And it's the proteins that are expensive as far as need for nitrogen is concerned. And our nitrogen removal currently in Ohio is about 0.6 of a pound of nitrogen per bushel of corn. And expensive nitrogen. We put on perhaps 180 pounds of nitrogen in many of our high productive corn acres here in Ohio. And so with 170 bushel average yield for Ohio, we remove about 100 pounds of nitrogen. So we really don't have a need for that 180 to 220 pounds of applied nitrogen. And of course, that excess nitrogen costs money and then creates environmental concerns because loss of nitrogen, nitrates in particular, goes into our water bodies, can lead to excess algae growth. So here's some data. I guess we'll take a quick look at that. This shows Ohio conditions with 80 sites. These are corn and soybean rotation. And each one of the dots on this slide indicates a yield trial that was conducted. And so I'll just point out here, optimum yield. I mean, I'll put it in those terms. It says optimum yield, but I'll say yield is on this axis, nitrogen rate across the bottom. So I'll walk quickly through a few of these. So this dot here represents that the farmer applied perhaps 15 pounds of nitrogen through his planter. That was the highest economic return for the amount of nitrogen he applied. And so even though he may have put on higher rates of nitrogen, 50, 100, 200 pounds of nitrogen, economically, even though we only made 120 or so bushels of corn per acre, that was the best use of his nitrogen, and that was all that went through the planter. 3 dots up here located around the 75 pounds of applied nitrogen has a return of 250 bushels per acre. So again, a very low amount of nitrogen has provided great returns. Point out a dot down here, another yield trial. And so the farmer in this case put on a set of nitrogen rates leading up to something approaching 200 pounds of nitrogen, and yet it took almost 200 pounds of nitrogen to get that highest economic yield. So bad year, bad conditions, dry weather for the most part is when you see things like this happening. But that was the highest economic return. And then you see a whole lot of dots in this middle range here, which really to me indicates we have an average yield in Ohio of around 170 bushels corn per acre. It's just how much nitrogen it takes to get there depends on the weather. We talked about earlier, what kind of conditions we have. It's not just rate based, but weather conditions as well. I put a red line on here just to think about something. If you would believe or would follow the old yield by rate recommendations, this would be the line that you would follow. And you can see that most dots do not fall on that line anymore. A little bit of trial rate work here. This is some work I've done at the South Charleston Research Station. This is over a 2010-2014 time frame, and this is 528 data points, just showing the range of what happens for our applied rates. I'll start off first with over here on the left side, where the 0 rate was applied. It indicates how much mineralization we have from our soils. And at this site, we have 66 pounds of nitrogen mineralized on average over the year, or per year. And then that range may be from 38 to 95 pounds per year, depending on conditions, growing conditions. You do see that, yes, we get a response at these lower rates from 0 to 50 to 100 pounds of nitrogen, a pretty dramatic response. Then it flattens off, levels off perhaps as we go up to the higher nitrogen rates. So if we think about economics, somewhere in here, in that 150, maybe down even as low as 100 pounds of nitrogen is going to be our more economic point for our maximum return. And we see we can also here probably our maximum yield on here somewhere around 260 plus bushels of corn per acre. We could still make that with 150 pounds of nitrogen. It doesn't take this 200 plus pounds of nitrogen to maximize our yield. So what do we use today? We have an economic-based nitrogen rate calculator, currently called the Corn Nitrogen Rate Calculator, also called our Maximum Return to Nitrogen Calculator, MRTN. You may hear that term used before, but this is the current tool we use for recommending nitrogen for Ohio. This would give us our most profitable nitrogen rate, not our highest yield, but our most profit per acre. And this does use our yield trial work from Ohio, and you combine that information with the price of corn, nitrogen price, and then also whether or not it's corn-soybean rotation or a corn-corn rotation. It does take a regional approach, and so we are actually working with 5 to 6 other states to try and put this information together, but the data used for Ohio would come from Ohio trial work. As I said, it's web-based, and you can see the website there. But cnrc.agron.iastate.edu, so it's at Iowa State University. So it's an online calculator. You're welcome to go there and do some scenarios for yourself. Here I've run one for some Ohio conditions. Again, we use that corn nitrogen rate calculator. Again, it's the maximum return to nitrogen that we're looking for. So I used Ohio as a location, a price of nitrogen 40 cents a pound, $3.65 per bushel of corn, and a corn-soybean rotation. And the MRTN recommendation rate today would be that 170 pounds of nitrogen per acre over a profitable range of 155 to perhaps 186 pounds of nitrogen. And you can think about some scenarios running there. Perhaps, if we have a little bit more concern about our nitrogen leaching, maybe we'll run toward the 155. If we think we have, dry conditions, whatever, we may run a little bit higher. Not necessarily we need to go to those higher rates for higher yield, but the conditions under which we might lose more nitrogen, or rather not make more nitrogen available. And then we can expect, percent of maximum return perhaps at 98%. So we're not going to maximize our yield. We're going to maximize our economics. And just put it here in chart form. You can see that over this range here in the center, that's a blue range, that's that profitable range. So 155 or so on the low end up to about 185 on the high end. I do point out here in this blue line at the top, yes, we do get an increasing yield with increasing nitrogen up to a point, but that's also the point. This nitrogen costs us a lot of money. This return from this nitrogen costs us a lot. Returns here are much greater. And so when we get to that inflection point, that's when we need to think about finding that nitrogen rate in that range. Timing. So can we delay our nitrogen application? The charts I talked to you just here moments ago about on MRTN set a rate, but they don't necessarily talk about timing. And we can reduce the risk of loss if we delay the time that we apply the nitrogen. So here's a chart from University of Illinois. It's from an IP&I report, but it shows uptake of nitrogen over the season. And you can see here that at very early in growth of corn, up to perhaps V8, we really don't need much nitrogen. We do have this grand growth phase, whatever that occurs in here. Yes, we need to have nitrogen in place so we can have that available for corn, but we really don't need a lot here in science. So there's potential for delaying our nitrogen to somewhere in this point here does exist And just again, just to emphasize a little bit more, at V8, perhaps you only need 40 pounds of nitrogen. So again, think about how we can delay that nitrogen. Here's some work that Peter Scarf summarizes across some multiple state delayed nitrogen application. And just show on the chart, here's the growth phase across the bottom. And then over here, he used a normalization curve, whatever normalization point, where so 1.0 would be equal to 100% of the yield. And you can see we can get out to 4 feet or so tall corn before we really need to worry much about whether or not we have nitrogen out there. Peter does point out that these trials were conducted with no nitrogen applied until this point, and you can see that yes, if we delay too late, we can get some yield loss. My recommendations for Ohio would be to apply perhaps 30 to 50 pounds of nitrogen at planting, and then follow up in season with a side dress application. And generally, I believe, generally would not see this delay until you get way out in here.